For the problem solving seminar, I had challenge number 3, which said, during a recent census, an eccentric mathematician told the census taker that he had three children. When asked their ages, the mathematician replied, the product of their ages is 72, and the sum of their ages is the same as my house number. The census taker ran to the door and looked at the house number. I still can't tell, she complained. The man replied, oh, that's right. I forgot to tell you that the oldest likes chocolate ice cream. The census taker promptly wrote down the ages of the 3 children. How old were they? So if we picked out some highlights to help solve this problem, the first one would obviously be that there's 3 children. The second would be that the product of their ages is 72. And then another one would be the sum of their ages is the same as the house number. And then the last one would be that the oldest child likes chocolate ice cream. And then some questions that I would ask about this situation is, what does ice cream have to do with anything? And then another thing I would ask is, it says that the sum of their ages is the same as the house number, but how are we supposed to know the house number? So I just broke down the problem into these highlights, and since we have to know the product of their ages, I started by finding all the products of 72 using 3 numbers and got these. And then I figured out that if the sum of their ages is the same as the house number, then we needed to find the sum of all the numbers that were also a product of 72. So I found those and stared at them for a long time and didn't understand why the census taker wouldn't just automatically know the ages of the children by looking at the house number, because if she knew the house number, she could just look at the list of products and automatically know. So I guess I started by saying, well, these first 3 aren't really realistic, because there's not going to be 2 1-year-olds and a 72-year-old for his children, and there's not going to be a 1 and a 2-year-old and a 36-year-old, and there's not going to be a 1 and a 3-year-old and a 24-year-old. I mean, there could be, but it's not a very high possibility. So these are all the possible products of 72. And then these over here are the possible house numbers. So if we look for similarities or patterns in these house numbers, the only thing that wouldn't automatically tell her what the ages of the children were the 2 14ths, because they're the same number. So if she looked at the house number, she still didn't know then it means she still needs to figure out between these two numbers which age the children were. We can see that there's 2 3s in this one and there's 2 6s in this one, which means that there has to be a set of twins in the family. And then we have to go back to our questions, and what does ice cream have to do with anything? So the oldest child likes chocolate ice cream, which means that there has to be an oldest child, which means that this set of numbers would be the ages of the 3 children. So the census taker started by finding all the products of 72 because she knew that there was 3 children and the product of their ages was 72. And then she found the sum of all those products and then took out the ones that were just unrealistic. And then based on those numbers, she found the only similarities and went and checked the house number and knew that the house number was 14, which means the ages were either 3, 3, and 8, or 2, 6, and 6. And then she went back and looked at the information that the dad gave her, and there had to be an oldest child because the oldest child likes ice cream. So it had to be 3, 3, and 8 for the ages of the children.